Hello, I'm ETarte, math teacher. In this video, I'm going to discuss sequences and series, specifically arithmetic sequences and series, and near the end of the video, I will offer you a challenge question. A sequence is, by definition, a list in which there is a specific order, a first element, a second element, a third element, and so on. The list could conceivably contain just one element, or it could contain some larger specific number of elements, such as exactly 10 elements, or exactly 57, or exactly 1,300,000, or it could go on indefinitely. Now I'm going to focus on a specific kind of sequences, arithmetic sequences. An arithmetic sequence is by definition a list of numbers in which you add the same number each time to get the next number. Here is an example of an arithmetic sequence: 38, 41, 44, 47, 50, and so on. Notice that to form the sequence, I start with 38 and then I add 3 each time. That number that I'm adding each time, 3, is called the common difference. And for any arithmetic sequence, I'm going to call the first term A1, the second term A2, the third term A3, and so on, and the common difference D. So for any arithmetic sequence, we start with the first term A1. To get the second term, I take A1 and add D to it. So A2 equals A1 plus D. If there's a third term, I can get it by taking the first term and adding D twice. So A3 equals A1 plus 2D. If there's a fourth term, I can get it by taking the first term, A1, and adding D 3 times. So A4 equals A1 plus 3D. And if there's a fifth term, A5 equals A1 plus 4D. Notice in each of these equations, the multiplier with D is 1 less than the subscript that indicates the term number. For example, this 4 is 1 less than 5. And therefore we can generalize. We get this general formula for the nth term of an arithmetic sequence. An, the nth term, equals A1 plus n minus 1 times D. This is the way I taught arithmetic sequences when I taught at Kingwood High School. My experience with tutoring Kingwood High School students is that for the most part, maybe entirely, this is not the way it's done by other teachers. Generally, other teachers at the school simply present this formula without explaining why it works or where it came from, or without trying to get students to discover why it works or where it came from. But now I can use that formula to find some term in the sequence that is far, far from the beginning. Suppose I want to find the 146th number in the sequence 38, 41, 44, 47, 50, and so on. So using this notation, I'm looking for A with the subscript 146. By the formula, it equals A1 plus 146 minus 1 times D. Well, A1 is 38, 146 minus 1 is 145, and D, the common difference, is 3. That's the number that's added each time. So we have A 146, the 146th number in the list, equals 38 plus 145 times 3. And that equals 38 plus 435, which equals 473. So 473 is the 146th number in this list. Now, if I insert plus signs between terms of an arithmetic sequence, I have what's called an arithmetic series. So here is an example of an arithmetic series consisting of 5 terms: 38 plus 41 plus 44, plus 47, plus 50. And of course the plus signs indicate that we are to add those numbers, and we would be looking for the number that they add up to, the sum of the terms of an arithmetic series. If Sn represents the sum of the first n terms of an arithmetic series, this formula tells us how to find that sum. Sn equals n divided by 2 times a1 plus an. Teachers present that formula and then give the students problems to work using the formula. For example, using this formula, we can now find the sum of the first 146 terms of this arithmetic series. So, using the formula, S146, meaning the sum of the first 146 terms of the series, equals 146 divided by 2 times the first term, which is 38, plus the 146th term, which we found up here to be 473. That works out to be 73 times 511, which is 37,303. So that is the sum of the first 146 terms of this arithmetic sequence. Well, I strongly take the position that this is not the right way to teach this topic, namely to present this formula with no indication of why it works. When I taught this topic at Kingwood High School, I either explained why this works, or even better, I tried to get the students to discover why it works. So that is my challenge to you. Why does this formula work? If you can answer that question, please don't do so here at the comments section of this video. Instead, go to my profile page, click on Send Message, and message me your answer. If you are correct on your first try, you can have a prize if you want it. The prize that I offer is an audio file of me playing my piano, a selection that I recorded many years ago from my archives. I recorded it during the days when I was teaching that topic at Kingwood High School. If you need help deciding whether you would like the prize, you can find at my profile page one of my piano videos playlists and watch one or more of those videos. If you do want the prize, please request it and include your email address. In any event, I hope that you have enjoyed this video and that if you work on the challenge, it will give you mental stimulation and pleasure. Thank you for watching this video.